Hi everyone again. Happy to meet you there. My name is Emeli and I'm, as Greg told before, CTO at Evidently AI. So at Evidently we build a tool to monitor and analyze machine learning models. And this is why today I'm going to share with you some tools on how data drift can serve us as an early monitoring for machine learning models. So there are a lot of different things that can happen with machine learning models since we put them in production. And in most cases, when something is wrong with the model, that's because the input data is wrong. And there are, frankly, a lot of things that can happen with the input data, starting from the data processing issues, data schema change, especially when we use some external APIs or databases, or the data can be even lost at the source, which once happened to me when there was a physical sensor, temperature sensing broken, but the value that it shows was still in the expected range, and yeah, it was pretty hard to catch it. But yeah, even if the data engineering team had their job done and there is no issues with the data quality and data integrity, there are still some things that we should care about. So first is the concept drift, which is the change in our target function. And this change can be gradual, which is accumulate over the time, or it can be sudden. And the recent pandemic is the perfect example of such changes. Almost over time, a lot of patterns has changed and many machine learning models became irrelevant. And together with concept drift or separately, we can face a data drift. This is the case where we see the changes in the features that we use, and this can happen just because the world is dynamic, right? Many things is changing. And for example, if you have some churn prediction model where you have a lot of users coming from different channel, and once your marketing team run very nice campaign and attract a lot of users, then the distribution of user acquisition channel can change because, for example, instead of a lot of users from paid search, you can face a lot of users from social media, social networks, right? And in this case, model's quality can degrade a bit or heavily, depends, right? So how to account for it? Of course, monitoring. And one can say, okay, but we have a lot of production services for ages. Why should we care about machine learning specifically? The answer is because together with the service health, we should account for data health and model health. And we are pretty convenient with the model health since we have a ground truth because, well, we can estimate a lot of quality metrics based on the comparison of our model's output and the ground truth. But what should we do when there is no ground truth? For example, when we have it with a delay. In this case, I believe we should care a lot about data drift and concept drift because this is the signals that we have, let's say, immediately. Because, well, since we can generate some models output, it already means that we have some features and then we have this output, right? So we can compare our output with the output we had, for example, at training or on top of our historical data during the experiment phase. And we can compare the distributions of output of input features and see if it meets our expectations or not. And here I dare to share some code. Hopefully you'll enjoy it because, well, I'm going to share how I can create the dashboard using Evidently. It's open source, and I believe for some of you it will be quite interesting and useful. So we are going to play around with the well-known dataset. It's dataset about bike demand prediction, where we have a lot of information about the weather conditions, and we need to predict how many bikes will be taken to rent. So this is the dataset we have. There is an information about temperature, humidity, wind speed, and the target is the count, the amount of bikes which is taken to the rent. So first of all, as all data scientists usually perform some feature engineering to create some interesting features. So let's add information about months, hour, weekday, because it have very strong influence on the amount of rented bikes, right? So that's how our data looks like. And before build the dashboard, we need to perform some labeling. So let's create the target variable, which is a count, because we need to tell later evidently where is our target. And let's create a list of numerical features and categorical features. So here it is. Then let's split our data into two parts in order to simulate the two data sets, reference data set where we train our model, and the production data set, the data set from the production stage where we use our model, right? So now we have everything to build the dashboard, so let's do it. Evidently can parse the structure of data frame automatically, but when you have some interesting cases like categorical features encoded by digits, because this is what we do for training machine learning algorithms often, then it makes sense to create the Python object Python dictionary column mapping and tell evidently straightforward, where you have targets, numerical features, and it will help to parse the data correctly and apply correct statistical tests. So here it is, and now we are ready to create our dashboard. So for doing this, we just call the dashboard object. This is the object we imported earlier from Evidently, right there. So to generate the dashboard, we just need to select the tabs we are going to build, which is data drift and numerical target drift in our case, and then just run the calculate method where we pass the reference dataset, which is pandas data frame production dataset, and our column mapping. So that's it. It's generated, and in order to see it, we just need to run method show from our dashboard object. So here it is. It's loading because we have a lot of visualization there. So it's pretty convenient because you have all the visualization available in your Jupyter notebook, and that's how it looks like. So our dashboard contains from two parts, data drift and concept drift. So here we can see that 4 out of 6 our numerical features are drifted. So we can open up any of features. For example, let's open the temperature. And you can see that yes, the distributions are different. We can pretty much see it in the preview. And if we open it, you will see that the temperature during the reference period of time was lower, right? And starting from 12th of February, it started to increase, right? This is why actually data drift is detected, as you see from table. And you can move to second tab, which is data distribution, and see that, yeah, distributions are different. And of course, same information is available for all the rest features, so you can open up and see how it looks like. And the second part of the dashboard is target drift, which showing us that the distribution of target function is actually also changed. So the demand for bike is increased for February, which is basically depends on the weather, right? And the weather became better, so more bikes are taken to rent. And this is how you can analyze what is happening with the data. So in case you have the ground truth with the delay, you can calculate the data drift, you can calculate the concept drift for your model's output, and if you see the changes, then this is a pretty straightforward signal that you might experience some problems with model's quality soon, and maybe it's time to intervene. So there are a lot of nice visualization available here. Just come to see what we have in our GitHub. It's open source. And my last observation is that often we're using some prediction pipelines, and it's not that convenient to use HTML reports to analyze the quality. And for these cases, we also have the profile, which is the same report but in JSON format. So for building it, instead of dashboard, you can call the profile method, and it helps to generate the report in a JSON format, so you can easily derive any part of the report, such as p-values for statistical tests, or maybe some information about distributions, and easily integrated into any tools like MLflow or Airflow or other tools you use to automate your machine learning pipelines. So this is basically all I wanted to share with you today, and we'll be happy to answer any questions later on.